Today, what I want to do is I want to give you the foundation of how to develop applications on Openshift. And the agenda for today is going to be, I'm going to tell you a little bit about what PaaS is. Then I'm going to go into architecture. I'm going to show you where Kubernetes fits in the picture, where Docker fits in the picture, and where Openshift fits in the picture. I'm going to go through some concepts, some terminology, before giving you a live demo of an application that's running. In the end, I'm probably going to ask one volunteer, or maybe more than that, to go on a website and type in something, and it's going to be persisted to a Mongo database running in Docker. And I'll have the front end running Node.js. So I got a lot of stuff for you guys, but first, we're going to go through the concepts and try to understand the foundation. So, Openshift is a PaaS, platform as a service. So it runs on top of Kubernetes, and Kubernetes runs on top of Docker. So Docker is an OS virtualization system that lets you do a lot more than traditional virtual machines, right? As you saw the presentation right before my presentation, he gave a lot of really nice demos and went through the Docker file. So if you guys have any questions, please just interrupt me at any time. I'm more than happy to go into any details. So you don't have to wait till the end for Q&A. You can ask me anytime. So this is the stack. So you got Docker, then you got Kubernetes that does the Docker orchestration. And then you have the PaaS on top of that to manage things and do a lot more for you. So PaaS, Openshift. What do I get from developing my applications on Openshift, right? So it's self-service, polyglot. So nowadays, folks work on big teams, and sometimes they work with a lot of teams. Some teams want to develop their application in Java. Some teams want to do it in Node. Some teams want to do it in Python, right? And they got their Docker containers. They give you a REST endpoint, an API you can communicate with. So folks are able to develop polyglot applications in multiple different languages, put them in containers, have a REST API in front of it, and have applications be able to integrate with each other more seamlessly. Thanks to Docker, thanks to Kubernetes, and thanks to the Openshift team for allowing those functionality to be available. So there's a lot of automation as well. There's a UI I'm going to show you. There's also scaling. So if you have a Docker container, right, and you got requests coming in, so you have a certain amount of CPU, certain amount of memory, how about scaling it across, creating more containers? What if your container dies? What do? So there's technology to solve those problems. So Openshift is something that usually people do on-premise. So for example, some folks want to do cloud computing, public cloud, and then there's private cloud, right? So some folks want to do their cloud internally, private. They want to run their stuff in Docker containers, and they want to have microservices. So Openshift allows those types of opportunities. So let's just go into a little bit of the cluster architecture of what does a cluster look like when you're dealing with Kubernetes and Openshift. So as I mentioned previously, Openshift runs on top of Kubernetes. So it follows the same principle. So you have a master, which is that blue box over there, which is a scheduler and manages the cluster nodes. So these are minions. I think they changed the name now. They call it Kubernetes nodes. But these are minions that go and do work, schedule jobs, create containers in there. So usually it's good to set up nodes in different data centers. For example, you might have one data center in the East Coast, you might have a data center in the West Coast, and then you have your pods get scheduled on those nodes. So I know I haven't covered the pods section, but it's coming. So this is the Openshift architecture. So you have the routing layer, which I will explain in a few slides. You have the persistent storage, which will come up in a few slides. It's a way that usually when you have Docker containers, if that container dies and you have data on there, you lose your data. But what persistent storage allows you to do is you can mount a volume, and then you can set up persistent volume claims and persistent volumes that are mapped to maybe network file storage, or maybe Ceph, or maybe even Cinder, or a lot of other, or even Amazon EBS, right? So there's a lot of options in terms of how do I store my data and keep it safe somewhere, right? And then we have services, because pods are going to die. They're going to come to life, they're going to die, and that's the life cycle of a pod, right? But we have a replication controller that's going to, if it dies, it'll create a new one, right? But our services is that layer that allows you to get your request in. So what we're going to do is, give me 1 second, running low on battery. But so pods are unique, and they have a unique IP. These IPs change, and they're not guaranteed to be the same. So the thing with pods, if your IP is going to continuously change, then how can you actually set a service to say, listen to this IP address, go to this host, and pull data from that web service if that IP keeps changing? So pods are great. They let you have one shared IP address among multiple Docker containers. So the boxes that you see in the middle there, you see a Tomcat, you see a MongoDB database, and you see a bunch of other containers in there. All those containers can communicate together in that same box. And this is like just basically a package. For example, you have a bunch, like 2 or 3 Docker containers, and you want to package them together and have it shipped as one piece. And this node can get scaled out. So you can scale it out to 3. You can tell Openshift, okay, make sure I have 3 instances of this pod, and if one of them dies, bring it back to life. So now we're going to go a little bit further, right? So we have 2 of our nodes, right? We have 2 of our nodes. It has the 2 or 3 or even any more than that Docker containers, and it sits behind something called a service. So we're going to talk about service discovery. It's coming up in a few slides, but I'm going to just briefly touch on it a little bit. So remember how I said pods are something that has an IP address that can change. So if I'm developing applications, I don't want to hard code an IP address. If I hard code an IP address, that IP address changed, guess what? I can't access my data. So services let you have one static IP address that lets you make requests and let you discover other pods that are running, other containers that are running within your cluster. So the environment variables are something that get injected into the Docker pod, and they're shared across the cluster, right? So when I have a web application, right, and I want to run it in Kubernetes Openshift, right? How does a user type in his browser and hit my Docker container, we have a concept called routes in Openshift. It's not a Kubernetes concept, but it's an Openshift concept. So our routes are based on HA proxy. There's something available right now, it's called Nginx Ingress, which is something similar to this. That's a Kubernetes thing, but I'm gonna focus more on this piece here because I wanted to nail this concept of, you have a route that knows an IP address of your service, right? And it'll make a URL, and when you hit that URL, it will go through, hit the service, it'll go through the service, and it'll hit one of your pods. If you said you want to scale this out, you want to have 3 pods, then it's going to either hit one of these pods. You have other clients that are hitting the same service, they might hit pod number 2. Another client might hit pod number 3. But routes are something that gets set up by an administrator. They're containers also, so they have their pods. And now we're going to get into service discovery, right? So when you have your application, as I mentioned before, and you don't know the IP address for that application, right? You can discover these services using environment variables. So in your application, you can just basically discover where's my Mongo database going to be hosted, pull that environment variable, and then read from your database. Whether you're using, any other, database solution, there's a lot more out there, but Mongo is the example that I'm using today. So basically, the environment variables are going to follow this pattern: service, name, service address. The second part is something static, and then the first 2 words are going to be something that is more dynamic. So now that we know a little bit about Docker and how they fit into Kubernetes and OpenShift, now let's talk about deployment, right? So I'm developing a Java application, for example, or a Node.js application, and when I write my code, right, I'm working with a big team of engineers, right, and somebody deploys some code up, right? I have my stuff running in development. I don't want to disrupt the team, so there's this concept of rolling update. Somebody might be testing some stuff, they might be using the application to look at some stuff. I don't want anything to go down, right? So there's that concept of rolling deployment. So what rolling deployment is basically is, you have your old application code, and then you have your new code. And then if you have it clustered out, like scaled out, multiple pods, then what happens is the rolling process takes one pod down, it creates a new pod with a new code, then it does the next one, and then the next one in the list, until it rolls out your new code. There's another way but that's a default way, but a different way of doing things is, if you don't care about downtime, and you just want to just get everything deployed, and you want to rip out the pods that are currently running, then what you can do is you can use recreate, which what it does is it shuts down all the running instances of the old application, and then it deploys the new one. And if you're interested in more of custom deployments, and if your use case is a little different, a little bit more complex, then there's a custom way to do deployments as well. So if I deploy an application, it's a web application, and one of the URLs is throwing a 404 or a bad request, for example, right? How do I make sure that Docker doesn't deploy my application when my service isn't running? The simple answer is health probes. So what health probes do is you give it a URL, and you say, if this URL is alive, then that means my pod is running and it's good. If this URL is not alive, then that means my application isn't good. So I want to know, I don't want my users to see that my application is down. I want to know, and I want the application to show me that it's not working. There's also script, a way to set a script to check and see if things are running correctly. And then there's TCP socket check. So you can check a specific TCP socket if it's up. So now that we covered the core concepts, we're going to get into security. So when you're running all these Docker containers, right? You might not want to give everybody access, right? You want to give a certain group of people access. Like, for example, if I'm working on in a company, I don't want to give access to every single team, right? So I'll have specific access for my team to work on specific things, right? So there's two levels of authorization. There's cluster policy, and then there's local policy. So you can set a policy to say that this developer, he can deploy applications, for example, or he can read what's running, but he can't, delete my router. He can't delete all these pods and do more advanced things, right? That could mess up my system. I mean, it solves the problem of giving everybody root access, right? But you don't want to give everybody root access. You want a little bit of control and have controls set in place where things are not going to be broken. So I was just going to go into a brief part. I could be talking about hours about this security policy and then going through each example. But I wanted to give you guys a demo, something that's running. So I'm going to go to the next step. So this is kind of setting the paveway of what my demo is going to be about. So we have this concept in Openshift called source to image, right? So you saw in the previous talk, they showed you a Docker file. You said, what is that? I got to write all those Docker commands. Docker has a lot of best practices when you're writing Docker files. And sometimes people don't know these are the best practices that they're implementing. Some people are running Docker containers as root. So we have controls in place within Openshift that make sure that when you run an application, it doesn't run as root. And also, which you can override if you want to, right? But basically, what it does is it takes your source code. So you write your Java application, you don't care about setting up Docker, and you don't care about writing Docker files, because you are a Java developer. So what you do is when you write your Java application, right, you check it into Git, which you can see over here. And once you check it into Git, I'm going to show you the process of taking that source code and generating a Docker image from that without writing one line of Docker. So what happens is Openshift will take that source code, it'll do a build. Once it does a build, it will go ahead and put that image, into its internal Docker registry. And after that, it'll go and deploy. And once it deploys, your application is going to be up. So what if some...
when it builds, how does it do it with a Docker file? Does it like produce a slug or something?
No. What it does is we have this technology called source to image. So it detects if you have a Java application, right? You're going to be using Maven, for example. And if you're using Maven, we do a build. And then once we generate your artifact, then we run it.
A standardized container.
Yes. So we build your source code.
Image on an image, right?
And then we create for you an image. And then we have that image ready for you to use. And an image that's not running as root. So you're going to see that in the demo. So now that I'm working on a team, right, I might have 2 or 3 developers, 4 developers, more than that maybe, right? And we're all continuously changing code, right? So if we're continuously changing code, and I have my stuff deployed up there, I don't want to be the guy that gets pinged all the time and say, can you deploy my code? Can you deploy my code? Can you deploy my code, right? So there's this concept of webhooks. So what webhooks let you do is you basically give that webhook to GitHub, for example. You set that in one of the configurations within GitHub, and that webhook will go and do a ping here, and it'll trigger another build to happen. So now what you have is you have something that's rolling out your latest code. So as I mentioned, it does build your container, but now that your code changes in Git, it's not up to date. So when you want to use webhooks, that lets you keep your changes up to date, and these are configurations you'd have to set in your deployment. So we talked a bit about persistent storage, how pods, when they die, you lose your data. If you have a database, you don't want your database to be running, and then your data's gone after your pod dies, right? Or maybe you might have a data center or something, and you have like, a bunch of machines. One machine, something breaks or something happens. You want your data to survive, right? So there's some options. So you can do temporary stuff, which is empty dir. Then there's host path, which you store it in a host path. Then there's network storage, which is a lot better. So if you're doing network storage, you have network file storage, which is not something new. Network file storage has been around for a while. There's Ceph, which is quite, emerging technology. And I believe RedHat acquired Ceph. There's Gluster FS, and then there's Amazon EBS volume. There's also Git repo, there's Cinder, then there's Google Cloud Persistent Storage, or persistent disk. So, but this is something you would have to set up yourself, because when you're setting up your persistent volume and persistent storage, you tell it how much storage you need, and you set all those configurations within your Kubernetes manifest file. So this is not something that's set up for you. You got to set it up yourself. So what about passwords, right? Passwords, you don't want to put it in your Docker file. You don't want to put your passwords in Docker files, and you don't want to put it on Docker Hub. Because for a simple reason is anybody can get it. Anybody can do whatever they want with it. But if you're developing your application and you want your secrets to be there, then you can set up secrets where this is going to be mounted on a volume, right? It's going to be mounted as a file. And when you set it up, you can have it in a way where basically it's stored in a volume and it's shared across your pod. And then you have it's shared within the namespace as well. You can do that. And also you can perform actions on behalf of the pod with these secrets. And it's basically this YAML file. This is a configuration file. And a lot of these concepts that I mentioned earlier, a lot of the stuff can be set up with YAML files. So you would maintain a YAML file that would do your configurations and setup. So labels are another thing that's quite important to know about, because it's a way that you group objects together. So if I'm deploying an application, right? And this application, I want to bring it down. I want to search for all instances of this application. Labels let you search. So you can do like OC, delete all instances of this app. I'll show you that in a demo. Then you can map services. For example, when services want to discover where your pods are, you tell the service the label, and then it'll go out and search for it, and it'll find your pod, and that's how they map together. So now let's talk about scaling, right? So it's not good enough to have just one Docker container, and that's your whole application, right? So when you want to scale out your containers, Kubernetes has this concept of replication controllers, which are responsible for replicating your pods. So on the left here, we have one Docker container. Then on the right, we have 3. We have 1 pod on the left, we have 3 on the right. We're using a replication controller. We're setting a configuration in there saying that we want, at all times, I want my application to be, I want 3 instances of my application always running at all times. So let's go into a demo here. So I got Amazon here, Amazon in EC2. So it's accessible through public IP address, so it makes it a little bit easier. I didn't want to develop something on my local box and then show you. I thought this was a little bit better. So I'm doing a 1 node on Amazon. 1 node cluster. It's not even a cluster, it's a single node Kubernetes environment, right? You could do the whole, 1 master and multiple minions if you want, but for sake of simplicity, I thought 1 node would be enough for us. So if we go over to this, right? We're going to go into the console, right? This is the Openshift origin console. All right, so I created a project for us. Usually, when you get to this point, you always create project, which is this, but I've already created a project. But it's an empty project, right? So we talked about, we want to see source code get turned into a Docker file. I don't want to write a Docker file, right? You want to develop code and not have to write a Docker file. This is the way. So I am going to go and get my Git URL. So this is my Git URL. This is a Node.js application, as you can see. This is a fork of the Openshift Node.js example, but I've added a lot more to it, which is it lets you, my example has a way to persist data into MongoDB within the container. But let's make this a little bit more interesting. I'm going to ask one volunteer to log in to the website that I give them and type in something and try and log into this, not log into this application, but just fill out the form, and we're going to see the information show up here. So it's going to ask you, like, what's your favorite food? And then you type it in and you press add, and it's going to be added to the list. And if more than welcome to have more than one person do it as well. So I'm going to set this up, and I wanted this to be a more interactive demo for that purpose. Okay, so I think I went a little bit fast. Let me slow down a little bit for you guys. So you're here. This is where you got to on the project. So first thing you do is you say add project. Okay. When you get to add project, there's a lot of templates already created. So a lot of these templates, they'll go and create for you Docker image, and then it'll deploy it for you. So there's Jenkins, there's Wildfly, there's Ruby, PHP, Perl, Python, Node.js, and a lot of other stuff, Elasticsearch, and also Kibana stuff as well. Then MariaDB and MySQL, right? But the one that we're going to go through is this one here, which I'm going to give it a Git URL, which is this one. Okay, and when I give it this Git URL, I want this application to go and fetch my Git code and create for me a Docker container. So let's see it in action. So it's doing the builds. It's doing the deployment. And now it's doing the build for the Node.js application. We'll check the logs as well, just to see what's going on there. But you know what? Let's look at the logs. So we want to know this build, what's the progress on it? Okay, so now it got to the point of building the Node.js application. And now what it's doing is it built the image and it pushed it to the local image registry here. And now it's successfully pushed. So that means we should have our container here. Okay. All right, so now that we have our container, let's take a look at it. So this is my application here. So I'll be the first person to put my favorite food in here. Fish and chips. That's my favorite food. Okay, I'm gonna put this in bit.ly and make it a short URL that anybody can type in their computer. Okay, so the URL is right here. So anybody who wants to do I have any volunteers here? Who want to give it a try? All right. You got it?
Nope.
But
Customer orders is gone.
one second.
Yeah.
Let's refresh.
Get food.
Okay. So there's been a lot of people on this site then.
Wow, people like sushi, man.
Wow. There's a lot of sushi fans here. And somebody put Zach Hassan in there. I don't know why, but I'm scared for my life right now.
You're my favorite, Zach.
I'm scared right now. But so we have our application. So let's check the logs. Let's check the logs and see what happened there, right? So we'll go into the application here, and we'll check out the logs, see what's going on here. So there's a lot of stuff here. So fish and chips, sushi. You guys can see the logs, right?
Oh, yeah.
Things are coming through. Apples. And where do we have Zach Hassan in there somewhere? I'm gonna find your IP.
Chips. Oh. They proceed.
Gotcha.
Find their IP quickly.
I'll find you somehow. So now that we're here, and now that we have an application there, right? So we talked about those concepts, right? Which was, we have a pod, right? As you can see, we have these pods here, 1 and 2. And then we have this, which is the build that completed. And of course, you can always check back and see, builds that changed. But I want to make this even more interesting, right? I want to go into that web application, and then I'm going to make a change. I'm going to push it to Git. I'm going to trigger another build, and let's see this application change. Maybe we'll change the title or something, make it simple. So yeah, let's make that demo a little bit more interesting then. So let's make this title something. Let's put in here, instead of favorite food, we'll do
Music.
music, yeah. Music orders. Okay, and this time no Zach in there.
You are my favorite kind of music.
All right. All right, so I'm gonna go into my terminal here and all right. So once again, good. So as you can see, just for the sake of no smokes and mirrors, you can see my git change here. Okay. And let's see. You'll see the actual changes now. So this is our build, right? It records our builds and it shows like all the builds and stuff, right? But what we're more interested in is the deployment here. So we want to trigger a deployment. So we can click this button, but I happen to be a fan of the terminal, so we're gonna be using the terminal. Okay? So basically I put that command in there, OC deploy the application. I want the latest application and I want it in my namespace, this project, FSOSS 2016, right? So I click that. So now it's doing a rolling deployment. All right. As you can see, it's taking down my Node.js application and it's bringing back up the latest code. You saw that, right? It was pretty quick, so. Okay. All right. See our build. Let's make sure we check and see. Nope. Still running. Yep, it's still running.
Oh.
Yep, so we got the latest one now. So it should be up here. Damn it, my browser. Oh my goodness. You know what? Let's do this. I am not hacking.
It's the pure volume for the web.
So what I did there was I just deleted everything and using labels. As I mentioned, I did promise I was going to show you guys how to use labels, and in this case I showed you how to delete everything. So now that we got there, this should be offline now, so. All right. Now we have nothing running except the old build artifact, but we can always solve. So these commands that I'm running, maybe I should actually cover these commands actually, because these are very important if you're going to be developing stuff, and a lot of times, you know, you're going to be using the terminal for a lot of system admin stuff. So OC is our command, and what it lets you do is it lets you do a lot of things like log in, it lets you deploy applications, it lets you set, you know, security, it lets you, but you have to have permissions in order to use a lot of those, you know, high security things. It lets you check builds, see a build success or failure. So if you don't want to use the UI, then you can just do a lot of your work off the terminal. But I wanted to show the UI because I thought it's a little bit more interesting than green screen. But so this is OC get pods, OC get services. We have nothing, and OC get all. But these are a lot of the commands that exist, right? So let's get back to our demo, and let's show the latest, movie application. Favorite movie? Music, yeah. I think I missed my coffee then. Yeah. All right. So there goes our build. So this time, let's just watch the build and see things building. So you can press this button here, follow, if you want to follow the build and see like the progress of the build, what's happening in the build, and then you're going to see the image getting pushed at the end. Okay? So since our build is done, our application is up. So let's see if we're in business.
Yay!
We are in business.
Good stuff.
So somebody did it. Somebody did it.
You are my music, Zach.
Oh my goodness, somebody's really quick at typing here. Okay. All right. It's like I'm favorite everything. I don't know. Favorite music, favorite food.
The whole time.
Okay, so now that you understand, so now debugging. Let's talk a little bit about debugging, right? So I have my application, great, it's on Kubernetes, Openshift, it's on the path, it's running. Something goes wrong, right? What do? Well, best thing to do is first, you just check what pods are running, right? So we can see our Node.js application is running, right? So now that our Node.js application is running, let's look at the logs from here, or maybe let's SSH into it. Let's go into that box, right? Let's get in here. Take a little bit. You know what? Forget that. Okay, so as you can see, the terminal, it lets us actually get inside the terminal and do things. So like I can check and see, okay, I deployed my code. Let's go into views. I'm pretty sure I put music there. For some reason, my changes are not showing up. So why don't I just get in this HTML file and let's see if my changes are actually in there, right? So let's see if my music change is in there. It's there, right? So you can do a lot of like debugging in your Docker container here within the web console. You can do it on terminal too. It's taking a while, so thought it a little easier and a little easier to read on the web console. So this tab is very important. So for example, if there's something that's not working, right? You can use this tab to kind of see when things break and when something goes wrong, right? And this is your environment variables. So for example, your Mongo database, username, password, and a lot of the things that the application is using, right, are here. So we are gonna quickly take a look at the server-side code. So let's look at how I connected to that Mongo database, right? So I have this Node.js application and it's connecting to Mongo. What I'm doing is I'm checking the port environment variable here, and I'm checking this Node.js application IP here. And then I'm also checking the URL for MongoDB. So once I take the URL, I set up using environment variables. I do a lot of my wiring, right? So I can probably like run this application, something goes down, it can come back up easily. And IP addresses change, right? As I mentioned, pods change, but when you use an environment variable, it's a lot easier to discover where your databases are, all right? So I'm actually getting to almost at the end. So I wanted to leave a little bit of time for questions or something that somebody's more interested in diving into more in depth. Or I'm gonna call it the end. Is there any questions? Yeah.
You mentioned that secrets are YAML files and that they're mapped as volumes inside the container.
Yeah.
What does that look like inside the container?
It's basically mounted as a volume.
But just
It's like a text file.
or
Text file.
okay. So
Yeah.
it's just a folder containing a single file, which is just the YAML file.
No, it's the actual username and password. But it's not available outside. It's only within your pod.
So a file hierarchy mirroring the YAML or what?
Basically taking the YAML and then pushing it to the Kubi API, and then that triggers the creation of the secret, and the secret gets mounted as a volume. And you have to mount it yourself. Like, the part I wanted to mention is within your pod definition, you have to actually say volumes, and then you have to specifically ask it to mount your secret. So that's an extra step that you would have to do. Sorry, you had your hand up as well?
Yeah. So if you are setting up a stateful server or service, and you have it running on multiple pods, how do you set it up such that the router makes sure that the ingress address always goes to the same pod?
That's called sticky session, and that's like a load balancer thing.
Yeah.
So why would you want to keep it going to the same one? Are you trying to do A/B testing?
Because it's stateful, the service requires to know, the service needs to know what it has already done for you to provide the next part of what it's answering.
Mm-hmm.
Such as logging into some of the web apps we run.
Right? I have to know that you've authenticated before.
Oh, okay. All right, so there's something called SSO, single sign-on authentication, right? So that's something that if you'd be interested in doing like single sign-on, right? Then what you would do is you would set up LDAP, right? Within the SSO. And then once you set up your LDAP, then the SSO gives you tooling to set up security where when requests come in, it gets routed to the SSO web console, and then it authenticates the user. But I think what you were interested in more is you wanted to develop your own authentication. I would suggest to take a look at the.
When a user goes to the website, they need to get directed to a specific container, whichever, it doesn't matter the first time. And then after that, they have to keep getting sent to that container where they're still logged in, unless that container goes down.
Okay, so then best thing to do in that situation, then create an application that talks to the Kobe API, right, and discovers which pods there are. Set the pod as a label, right, and then each request that comes in just redirect to that specific pod.
So you can make choices based on ingress address.
I got to double check on that part, but
Okay, yeah, I got an example now. Say I set up a bunch of containers called linux.student. However, when my student comes in over the network, I'm going to redirect them to one of the containers. If he sets up another SSH session, I want him to go to that same container so that he will see his processes that he's running. If he gets on a different container and does PS, he's not going to see the process he was running, right?
okay. Let's do this. Maybe I'll give you my Red Hat email,
Yeah.
and then you can just touch base with me afterwards, and I'll try and get you the information or whatever information I can help with.
Okay.
Yeah.
I think the question is if Kubernetes is really the right solution for this problem, right?
Yeah, and
It's
really more
stateless, it's
focused on
obvious.
stateless things.
Yeah, it deals with
ephemeral
stateless
things.
services, it can't deal with the need for stateful.
There is something on the roadmap. I'm not sure if that 100% will fit in Kubernetes.
Yeah.
It's more for clusters. Currently, you wouldn't want to run database clusters in Kubernetes really.
Yeah, this is more like a,
But it's probably something similar. They call it pet set. So you can.
yeah, pet sets exist.
Container.
Pet sets exist here in Openshift.
Yeah.
Yeah,
So you can
I didn't want to.
Container with a new container with.
I didn't want to talk about pet sets, but like, yeah, pet sets do exist, but that's another topic. And like I said, if you want, we can touch base offline.
So is this Openshift, for example, is that Red Hat's answer to sort of like OpenStack, but instead of for VMs and bare metal, it's for containers? Is that what Openshift is?
Yeah, and kind of. So like, so OpenStack is more of, virtual machines, and then you have a hypervisor, and you have that sort of setup, right? This is a little bit more lightweight for me, and this is my personal opinion, that this is more lightweight. You have Docker containers, which is more emerging technology, right? But I mean, some folks, they might want to set up VMs using OpenStack, and then run OpenShift on top of OpenStack, and then have their Docker containers on top of. Some people want to mix both, which both are viable options.
So you talked about service discovery through environment variables, but are there alternatives like a cluster DNS that I know is present in Kubernetes? Is that also something that can be easily implemented into OpenShift?
I mean, it's possible. It's possible, but I mean, the environment variables are like the tried and true. A lot of people usually use environment variables to do things like this, service discovery.
Okay.
Do you use a different scheduler with OpenShift, or do you have to use Kubernetes?
It's the same scheduler. It's the same Kubernetes. And like our engineering department, we have folks that help out with making bug fixes on Kubernetes as well. So yeah, we use Kubernetes. We pull in Kubernetes as a dependency to OpenShift. And this is also written in Go as well. Anything else? Thank you.